First up, we've got a quadratic cubic to try and solve. Let's try and factorize it. So I can put in values of x and use the factor theorem to get the factors. So let's go with the simplest one. Say x is 1, then I'd have 1 minus 4 minus 1 plus 4, and that does equal 0. So x minus 1 is a factor by the factor theorem. So now we can factorize it. You might be able to put it straight into brackets. I'm going to do it by doing a polynomial division. So we get x squared, and then we times back through, subtract, minus 3x, and then minus 4. So that means we've got x minus 1 times x squared minus 3x minus 4 is greater or equal to 0. Try and factorize it again. X minus 4, x plus 1 greater or equal to 0. Okay, I think I've got space to draw a cubic. So just like with the quadratic inequality, we tend to draw the graph and look at where it's actually going to be greater or equal to 0. Let's do that here. So a root is going to be 1 and 4 and minus 1. It's a positive cubic, so it's going to come up from minus infinity. Going to hit the axis at positive 4. I don't know where the turning point is going to be. That's not essential. It's going to look a bit like that. So where is it greater than 0? Well, it's going to be all values of x to the right of 4. So x is greater or equal to 4. And there's this region here where it's above the y-axis. So minus 1 less than or equal to x less than or equal to 1. Let's take a look at part 2. So now we're actually dealing with two-dimensional space. Find the 3 lines in the xy plane on which this is true. Compare it with the previous question. It's very, very similar, except there's just y's involved. So what happens when x is equal to y? We would get y cubed minus 4y cubed minus y cubed plus 4y cubed, and that would equal 0. So x minus y is a factor. And in fact, you might be able to see at this point, it's going to be basically the same thing as before. It's just instead of 1, we're going to have y. Instead of minus 4, we're going to have x minus 4y. And we're going to have x plus y. Okay, if you can't see that straight away, then try some other values. You would, or do a polynomial division. It would all work out, but this is what we've got. Just realized, sorry, it's equal to 0. And we can solve this in a very similar way. We're either going to get y equal to x when this is 0, or y equals a quarter x when the second term is 0, or y equals minus x. Those are our 3 lines that will satisfy this equation. And then finally, we're asked to do a very similar thing, but now it's an inequality. So let's sketch the region. Okay, first up, y equals x. I can draw this line, and it's going to be a solid line because it can equal 0. So along this line, we would get a solution for that reason. Now, I'll do this in green. I'll put in y equals minus x. It's only a sketch, remember, but just try and make it look like it's these appropriate graphs. And then we've got y equals a quarter x. So I'll just make sure that I have a less steep gradient like that. Yeah, you could try and do this algebraically, looking at where the terms, like some of them, we need basically two of them to be positive and one of them negative. So you could use that approach, but probably the best approach is just to try a point out. Let's just try x equals 0 and y equals 1, which would be here. Let's see if it's in the region or not. Then I might just resort to my factorized form, actually. It's going to be easier to substitute into. So I'm going to get 0 minus 1 times 0 minus 4 times 0 plus 1. So I'm going to get 4, which means that that is in the region, that point, and it must be that all of this is in the region. Now, there's actually a really quick way to do the rest of the question. When we swap over into below this line, then it's going to change sign, because now instead of y is greater than x in this part, but it's going to be y is less than x, which means that this one will swap around. What that means is that this will now be less than 0. So it's actually not going to be in the region. If I then go below this line, then that one is going to swap around, and we're going to have this double negative now, which takes us back. So it is definitely greater or equal to 0. If you're less sure about that, then by all means try some more points. If you tried a point in this region, it wouldn't work. But if you go with x equals 1 and y equals 0, then we're going to get 1 times 1 times 1, which is 1. You can see that it does work. And for that reason, we can shade that one as well along similar lines, because this one isn't going to work. It's going to alternate, and then this one isn't. So this gives us our entire region. Let me just show you why, for example, this point is not in the region. So I could go with x equals minus 1 and y equals 0 to check the region over here that I've highlighted. Then I'm going to get minus 1 times minus 1 times minus 1, which is minus 1. It's not greater or equal to 0. So that's evidence. And you could do similar with the other ones. But that is it. This is the region in the xy plane that satisfies this inequality. Well done.